Hi everyone, welcome back to Geeks for Geeks. In this video, we'll be discussing the problem word break, which has been previously asked in companies like Google and Microsoft. So let us quickly read this problem and see what the problem says, and then we'll start discussing this problem. So in this problem, we'll be given a string A. So a string will be given to us and we'll be also given a dictionary which will be consisting of n words. So our task is to find out if it is possible that A can be segmented into space separated sequence of dictionary words, and we have to return 1 if that is possible, otherwise we have to return 0. So let me explain this to you in a simple fashion. Right, so if you will see the second test case here, or even the first test case, so if you will see the first test case, so in the first test case we are having what? We are having I like Sam, then sung, then Samsung, then mobile. Okay, so these are the strings, these are the list of strings that are given in the list B. Okay, and then you have the string A given as I like. So the task is that can you break I like in such a way that at the end of the day you are able to get it either directly or indirectly inside the list. So if you will see here, I like has been given to you, okay, as the A string. So this is the whole string that has been given, and the B string is what? Like B, in the B string you have I, okay, then you have like, then you have Sam, let's say, and other rest of the other things are there. Now if you will see, so what can I try? I have to try out all the possible ways of breaking. Okay, that is one thing. What did I say? I have to try out all the possible ways of breaking. Why? Because suppose that if I had to do what? If I had to search for Samsung, in fact, if I only had to search for, let's say, Samsung, and let's say Sam was there and Sung was also there here, right? So in this case, what I had to do, like maybe I had to break it till S, right? And I had to check if S is present. Then I had to check AMSUNG is present or not. Or suppose if SA was present, then I had to check if MSUNG is present or not, right? So the rest of it is present or not. Okay, so this would be a sub problem. Now by doing this regularly, you will observe that what I would have done is, if I would have check till Sam. So is Sam present as a string? Like I have to check, I have to fetch this thing, I have to get this thing very quickly, that is Sam present inside the B list or not. So which data structure comes to your mind? Map data structure, because you have to search for the word quickly, right, if it is present or not. So which data structure comes to our mind? Map, right? So Sam is present inside, right? So then we'll say that, okay, now for Sung we will apply the same operation, right? So we'll solve the smaller problem. It's like solving a smaller problem, because you know in Fibonacci series, if you have to find the nth Fibonacci number, so it is nothing but the sum of the n minus 1th plus the n minus 2th Fibonacci number. So similarly here also, when you have been given a bigger string, so you check, you keep on checking that if you are able to find the starting part, right, till a specific point, if it is present as a word inside the list, okay, then for the rest of it, again you need to do the same process. So it's nothing but recursion. Okay, I hope that this part is loud and clear to everyone. Now after this, if you will see, so here also what will happen is, let's say if you will try to break down the first test case, so here if you just break I, say, then you will see that I is present inside, okay, and then you will say that for the rest of the problem I will try to search whether like is present or not, okay, because till I it is present, so like is present or not. So you will call the function and you will first of all check, is like directly present? Yes, it is present. So in that case you will say that since I was present and the rest of the solve function that you called, there you find like as well, so this whole part is present. But suppose that if we were given what, instead of being given this very easy test case, if we were given something like I like and then Samsung, so let me just cross verify this, I like Samsung. Yeah, suppose that instead of this, if we were given I like and then we were given Sam and then we were given Sung, guys. Okay, if this thing was given to us. Now if this particular thing was given to us, right, suppose that this list was having I, then like, and then Sam and Sung, and some other words were also there which were irrelevant. Then what I would have done is, I would have first of all, like I would be solving for this part, that what I have to search is, I have to search whether we can find I like Samsung or not, whether we can make I like Samsung or not, and we'll try to break it down. Now what I would have done is, first of all I would have checked for the starting prefix only, for I only I would have checked, is I present inside the list. Yes, it is. So I would have checked it using a map. It is present. So I would have said that, okay, now I will call the solve function, same solve function or same check function. I'll call for the rest of the string and I'll check that whether like Samsung I can generate from the given word or not. So is like Samsung present directly? No, it's not. If it was present, then I would have directly returned a true. Now what I would have done is, like, I would have checked that L is present. No. Li is present. No. Lik is present. No. Like E is present. Yes. So since Like E is present, then I will say that, okay, Like E is present. Now I need to solve the smaller problem for since it is present. So I need to solve the smaller problem and check whether Samsung is present or not. Either directly it is present or it is present in splitted format or not. Then I would have again called the solve function for this smaller problem. So you can understand that we are using recursion here, and we have to apply DP also, because a lot of sub problems will be there that are already calculated, and if a sub problem is already calculated, then we would not calculate it again. So I'll check that S is present. No. So then I'll make the substring SA. Is SA present? No. SAM. Is SAM present? Yes. So SAM is present. Since SAM would be present inside the list, by which I will check using the map, then what I need to do is, since this guy is present, so I'll say that, okay, if it is present, then let's call in the solve function whether sung is present or not, and I would directly get it. So either I can get it directly or I can get it in bifurcation. So since I directly get it that it is present inside the map, so I'll just return true. And if, like, basically if the current substring that I have taken, if it is present inside the map as well as the solve function that I have called for the remaining substring, if it is returning true, then we need to return true that the word has been found. So that is how we need to solve this problem. Let's try and write the recursive code for it, and then we'll try to optimize it using the dynamic programming approach as well. Okay, so here what we will do here is, you can see that we have been given this particular function that we have to complete. So the string is A and we have been given a list B. So firstly, the criteria is that we would be requiring to search a lot of words. So in that case, we need to do what? We need to first of all declare a map for ourselves, which can do what? Which can store the strings, that whether a string is present or not. So we can make a map, map of a string, right? And let's name it as bool here. Okay, and let's mark it as MP. Now after that, what I will do is I'll iterate through all the words of the auto I is to B. So I'll iterate through all the words that are present in the B list, and I'll insert them inside the map. So I'll say that map of I is equal to true. So basically I'll mark them as present. You can mark them as 1 also. Then after that, what we need to do is we need to return the recursive function or a solve function. Let's name it as solve function. That would be better. You can name it as anything that you want. Okay, then after this I will pass the string A, because initially I have to search for the whole string. I'll pass the map also. Initially I'm starting from which index? I'm going to start from the 0th index, guys. Notice that. Okay, then after that, what I'll pass is so this is the part that I need to pass right now only. And then after this, what we will pass here is we'll pass int recursion here. Okay, and then what we will do is we'll have the string, let's say st, the current string that we are having right now at this point of time, and then we'll also pass the map. So unordered map is what I need to pass here. Okay, unordered map of string comma boolean. So let me pass it by reference, and then after this I'll pass the index as well, right? So the index is the current index from which I'm starting. So what we can say here, we can say one thing, that if suppose I is equal to st dot size, right? So if we reach the end of the string, so this means that the whole string has been found. That is why we reach the end, because when we'll find the last, suppose that Samsung was present and sung was found, then after that the rest of the remaining substring sung was found, then I would have checked for the remaining part. So if I reach the end, then we can say that we'll return true, that or we'll return 1, that yes, it has been found. Okay, otherwise we need to check one more thing, that if suppose that the current string that we are trying to find, if it is present inside the map, so if the map.find st is not equal to map.end, if the current string that I am trying to find, if it is present inside the map directly, then I would return true. Without splitting it, I can say that yes, it is present, so that's fine. Okay, otherwise what we need to do here is, guys, we need to say that we will declare a temporary string, let's say substring, okay, initially marking it as null, and then we will start from the ith index. So let's say I will start a j loop. Let's say int j starts from I and j is less than the st dot size, okay, then we'll do a j plus plus here. Now after this, what we'll do is we'll simply say that here in the substring we'll add the ith character, okay, and then after this we will try to check. What we'll try to check is that if the map dot find this particular substring so far is not equal to map dot end. So if this particular substring is present inside the map, and at the same time what happens is, if it is present in this and the solve function for the remaining substring is returning a true, the solve function for the remaining string starting from I plus 1 index till the end, if it is returning a true, then we need to say that yes, it is present. So we will be passing what? We'll be passing the string st here, right? Or you can say the string a, then we'll be passing the map also, and I'll pass the index as I plus 1. So if it is returning a true, or you can say 1, then we can say that the current substring that I had extracted from the starting, it is present, and the remaining part for which the smaller sub problem that is there, the solve function is working for it, and it is telling us that yes, it is present. So in that case I would return 1 here as well. Okay, otherwise at the end of the day, when the loop is over, then you need to return 0, indicating that the string was not present. So I hope that this idea is clear. Now let's try and submit it to check if it is getting accepted or not. So it says that there is some kind of error, map.find st. Okay, I have written minus accidentally, so I'll just change this. Now let's try and compile it and check. I hope it should be working fine on the samples. Okay, so yeah, we have one more mistake. Substring plus is equal to s of I. I should write st of I because the actual string is st, or you can say a, but I have a habit of writing st. So yes, let's see. Now there's another error that and is not okay, solve function. Okay, I need to I think I had written solve here, so instead of recursion I should write solve here. Okay, so yeah, this was one mistake. Now let's try and compile it to check if it is working fine or not. It is not working fine on the sample test case that has been given to me. So let us check where I might be going wrong. So firstly, I have declared a map, right, and in this map if suppose that if for the st it is true, so the current string that I'm trying to find, let's say if it is directly present, right, so in that case I would have returned a true. Okay, that is fine. Otherwise what I am doing is I'm marking the substring as empty initially, right, and then j starts from I. Okay, so I should use st of j here. Actually I've used st of I, instead I should have used st of j, and here also instead of I plus 1 I should write j plus 1. So this is one small mistake because I was the current index that I was at, and now if the string from I till j is present, then from j plus 1 I need to find. So that is what we need to pass. So this was a slight mistake that I had made. Now I think it should work fine on the samples, and you can see it is working fine now. Let's try and submit it as well to check if it is getting a TLE or not. It will give us a TLE because this is not optimized. Okay, it does pass, but you can see that the time is high. So what we can do here is we can simply use dynamic programming here, and we can see that one parameter is changing. So I can declare a vector int dp, and like we can say that the size of the dp would be what? It would be a dot size, that is the total number of indexes would be n, right. So initially I'm marking the dp as -1, and then I'll pass this dp here as well. Okay, so it will help me to further optimize the code here. And here also what I will do is I'll pass vector int ampersand dp. Okay, now what we will do here is, like, we will check, what we will check is that if the dp of I is not equal to -1, so this means that if this particular state is already calculated, then we'll return whatever is calculated in this particular state, either 0 or 1. Otherwise, if it is not calculated, then we'll calculate it, and before returning we'll store it and then return it. So it's like you are storing it and then returning it. Here also, before returning 0, like you will store it and then return it, so that the next time you don't have to calculate it again. Let's try and compile it first, and then we'll try to run it so that it can work fine. So it is giving me one error. Yeah, in the solve function also I should pass dp here, right? So let's check if it is working fine or not. So you can see it is working fine on the samples and it should get accepted as well. Let's see. So you can clearly see that my code was able to pass all the test cases and it is getting accepted. Talking about the time complexity of my code, so the time complexity of the code would be nothing but order of n square, because in the worst case you will be iterating till that much time even if you are using dp, right? And this problem previously has been asked in Flipkart, Amazon, Microsoft. So I hope that you understood this problem clearly and how we can apply dynamic programming approach to optimize it. Thank you for watching this video, guys, and make sure to comment +1 if you understood clearly, and keep coding, guys. Thank you.